Welcome to PhD Science. I'm Paul Eiler, and I will be providing an overview of the student-driven phenomenon-based program for K-5. I'm also your support contact to help your science teachers plan and prep for each unit. PhD Science Text Edition is a comprehensive cross-curricular product that integrates scientific investigation and reasoning with grade-level teaks to aid students in understanding core science concepts through the exploration of authentic phenomena. At the core of PhD Science are the following four pillars for a K-5 phenomenon-based curriculum using authentic phenomena. The learning is student-driven. The curriculum is weaved together in a coherent storyline with rigorous engagement. In each module, students will ask questions as they investigate authentic phenomena and use this to understand core science concepts. And the phenomenon they're investigating is truly authentic. So just like real scientists would be, we want them to dig in and experience it firsthand. In every module, they'll gather evidence, develop models, and construct scientific explanations for why the world works the way it does. In a student-driven environment, teachers facilitate learning. The students own it. Students are driving the learning so they can find answers to questions about the world around them. When implemented effectively, students develop problem-solving and critical thinking skills that go well beyond passing a test for a single science lesson. Literacy is a key component of the PhD Science learning design, which also includes connections for math, social studies, geography, history, and more. The core texts the students read are not supplemental, they're truly core to the science lessons. Through award-winning trade texts, they learn about the phenomena and reinforce the reading skills. We do want to make sure students are building knowledge of concepts, not just memorizing science facts. Assessment opportunities happen throughout the module. Every lesson includes at least one checks for understanding that include evaluation guidance of what evidence to look for and next steps for remediation. Additionally, each module has 2 to 4 conceptual checkpoints, also with evaluation guidance that occur at the end of each concept to assess the student's mastery of the skills identified in each concept standard. I'm also excited to mention the STEM integration with the inclusion of engineering or science challenge that happens in each module that allows students the opportunity to apply the knowledge to help solve a problem. At the end of module assessment, students are given the opportunity to apply their knowledge they've developed over the course of the module in a completely new context, and they explain how it applies to related phenomena. Here's our K-2 module map. Here you can see the science topics students will be covering to build science knowledge over the entire year, as well as anchor phenomena for the first 3 modules. Topics were carefully selected to be relevant to students, so they serve as a point of entry to helping them understand core science concepts. Some of these modules also include those spotlight lessons that focus on a different science topic. We know that science is often a lower priority in a K-2 classroom. That's why the K-2 curriculum specifically meets the needs of young learners. For instance, lessons are shorter to account for student stamina, collaborative conversations, and accessible questions create dialogue and discourse. Our knowledge deck posters and cards have simple yet engaging text and imagery. Full-color science logbooks have icons, pictures, sentences, and decodable words that progress across K-2. And students use sentence strips, model cutouts, and other artifacts to interact with their investigations and their anchor visuals. Behind the core materials for the program, there are several other resources we have in place to help educators successfully shift to the role of facilitating student-driven learning in science. Here's our 3 to 5 module map, again showing the module topic and the supporting anchor phenomena. The program includes several different components, and these modules also include those spotlight lessons that focus on a different science topic while fully covering the specificity of each standard. So with 3rd through 5th grade, lessons are 35 to 45 minutes long with a launch, learned, and land structure. You'll find about 25 to 35 lessons in a module that focus specifically on the module topic and anchor phenomenon, some of which makes up spotlight lessons that focus on a different science topic. There are also 3 modules per grade level. That means there are roughly 100 lessons per year, lessons that are timed to be about 35 to 45 minutes. Since we have 100 days of science planned, you can shorten lessons and cover the full module or additional days so the program is flexible based on your school's needs. The components for every module include the Teacher Edition, which is rich with resources and supports to help teachers facilitate every lesson. No more big and bulky textbooks to mess with, because a printed science logbook is a consumable item, and students have one for each module in the grade level. PhD Projected is a digital resource that provides teachers with classroom slides to to cover each module for easy projection in the classroom or through our distance learning platform, PhD Science in Sync. Every module includes at least one core trade text, as mentioned earlier, about the literacy component. Finally, hands-on investigations are an integral component of PhD Science. Each teacher will receive kits complete with consumable and non-consumable items to conduct these hands-on investigations. This will save your teachers tons of time when preparing for these investigations. As we've all experienced during the last few tumultuous years, sometimes schools get closed, yet learning must go on. So we've designed a distance learning platform called PhD Science in Sync, where every lesson in the in-classroom curriculum is correlated to the in-sync lesson. So all the same science content is covered wherever student learning may take place. For the student lessons and investigations, all the in-class curriculum have been adapted to our virtual environment and video, including the read-alouds of the core text. The Science Journal includes fillable PDFs with interactive annotation tools focused on the essential learning of each lesson, including activities and questions for students to complete during or after watching each video. The teacher version also includes sample student responses. The Learn Anywhere plan is a pacing guide for teachers to support these daily lessons when students are not in class. Thank you for following along in this very brief overview. Again, I look forward to helping your teachers implement PhD Science in a successful way to ensure that all kinder through fifth grade students grow strong in all science standards.